Hello everyone, welcome to the VLSI design course. So till now we have finished the two major chapters. Our first chapter is the meaning of VLSI. So in that we have seen the various applications of VLSI, what are the job opportunities, how VLSI changed human life and all major applications in the defense, aerospace and the satellite communication. Later in the second chapter, we have seen the major digital design concept like combinational circuit, sequential circuit, their examples, and their applications in the VLSI projects. So now the next and very important chapter we are going to start is the introduction to the VHDL. So we are going to we are going to start a detailed understanding of VHDL language, how it is defined, its various data types, its various operators, and so many examples. So in that, firstly we'll start with the why HDL languages are required. So we'll start with the our first topic, why HDL languages required. Then subsequently we'll try to understand the complete scenario of the VHDL. So in that we are going to cover the VHDL code structure like library, entity, architecture, its data type, operators, subtypes, then the data types in signed, unsigned. Then there are various modeling styles in the VHDL: data flow, behavioral, structural, then the concurrent statement, then sequential statements. Then we'll start actual implementation of the projects, or you can say examples on the FPGA. So how to use the Xilinx IAC or Vivado tool. So that tool design flow we'll try to understand. Then we'll see how to port code onto the FPGA. Before that we'll see how to simulate the VHDL code, synthesize it, then FPGA placement route, creating a user constant file in a Xilinx ISE, implementation on actual hardware platform like FPGA. Then we'll see some combination logic examples using VHDL and their implementation on the FPGA. So all these things we are going to cover in this introduction to VHDL chapter. This is a very huge and very interesting chapter. So here it is, we are focusing on the VHDL language, the programming and the implementation on the FPGA. So let us start. So why HDL? What is the meaning of HDL? So HDL means hardware description language, as well as it is called as a hardware design language. Why design language? Because this language is used to design the hardware. That's why the name is called as a hardware description or a design language. So this is a very specialized computer language used to describe the structure and behavior of electronic circuits, and most commonly we call as a digital logic circuit. So we have seen the digital logic circuits in our earlier lectures, that are the combinational circuit, sequential circuits and state machines. All these are the digital logic circuit. To represent that logical circuits, these languages are used. So why these HDL languages are required? What is the need of that language come into the picture? So in early 1970, in our first chapter we have seen how VLSI is started or when it is invented. So in early 1960 the first integrated IC was developed, and after that the VLSI started. So initial in early 1960 a small scale integration ICs are fabricated, then medium scale, and in 1970 actually the very large scale integration IT integrated circuits are going to fabricate. Because of that it becomes a very complex design. It will be very difficult to draw on a paper because the number of gate counts are more than 10,000 lakhs, and it goes into the millions, and nowadays it is in the billions. So this many of circuit design we cannot do on a paper level. So because of this, the VHDL or HDL languages come into the picture. So how it helps? So circuit designers needed a digital logic description to perform at the high level without considering the actual technology implementation like ECL, TTL or a CMOS. So HDLs were created to implement a register transfer level abstraction. So what is the register transfer? So the memory element we are calling as a flip flop, latch are called as a register transfer level. So these are called as a registers as a memory element. So along that we have other combinational circuits like gates, mux, demux, encoders. So all that are implemented using this HDL language. There are two major HDL languages. One is the VHDL, other one is the Verilog. So both the language are implemented for the same purpose. Their output, their execution, and the end product is almost exactly the same as a hardware implementation. But their syntax, their writing methodology are totally different. So we will see, we'll focus on the VHDL in this VLSI design course. For Verilog will create a separate VLSI design course. So in this design course we'll focus on the VHDL only. For Verilog we'll create another one VLSI course specifically for the Verilog and system Verilog sessions. So let us start with the VHDL. So these HDL languages basically are executed in a, or they are also called as a concurrent programming language. So what is the meaning of concurrent? Concurrent means the execution of statement in a parallel fashion. So we'll see the exact difference between the our normal C language and the HDL language in next few slides. But we have to understand what is the concurrency and what is the sequential. So sequential means step by step execution will happen, and in concurrence parallel execution is happen. Why concurrency is very important in the HDL or in case of the hardware design? Let us take an example of let us take an example of AND gate. Okay, so in an AND gate, let us take one more implementation of AND gate as, let us consider in a medical instrument. In a medical instrument, if let us take there are two inputs, one is the temperature input and other one is the uh, we can say other control for the medical instrument. Okay, so whenever these two inputs has to come simultaneously, then and then some activity has to be done on the output side. So at the input of AND gate, your both the input should reach at the same time and should be processed at the same time and will create a result at a time. But if it is not a concurrent, that means if the inputs are not processed simultaneously, what will happen? One input will come, later on other input will come, and in between the result will be something different. So these things are not acceptable in the hardware design, and that will affect lot of hardware problems or actual design constraint in the actual applications. So that's what this concurrent programming language plays a very important role for any hardware design. Now in this HDL language there is very important concept is the synthesis. So this is the synthesis block or a tool which converts our HDL statements into a hardware. Synthesis, what it does, whatever we are writing our HDL statement or logical algorithms, that whole thing the synthesis tool converts into a gate level netlist, or ultimately we call as a converting into a hardware. So now we'll see the basic difference between the C language and HDL, because C language is everyone knows how it is executed in here. Almost in every embedded application C language is used, and we'll try to differentiate between the embedded C and the HDL, or we can take an example of VHDL. So C visually we call it as a middle level language. It's a mix of high level language and a assembly language. But VHDL is a hardware description language. It is used to implement for the hardware. C can only handle a sequential circuit. That is the very basic important difference between the C and HDL. C can only handle a sequential instruction. That means whatever the algorithm or statements we are writing in a C language are executed sequentially, step by step. They are not executed at a parallel fashion, and they cannot generate a hardware primitives. VHDL is a it can execute sequential as well as the concurrent statements. So that is the basic another one difference between C and HDL. C programs can be successfully written while keeping our thinking process like logical and algorithmic ways, but for a VHDL programmer needs the knowledge of definitely logical, algorithmic, as well as he should be knowledgeable about the hardware circuitry like FPGA, CPLD and the PLDs. Usually while writing a C code we are not worried about the resource consumption because this C code implement directly on the available chipset like processors, or we are utilizing the memory. But in case of writing a HDL code using VHDL or Verilog, we have to be very optimistic about the resource consumption. Why? Because whatever we are writing in the HDL, ultimately it is going to generate one of the integrated circuit or ASIC, or it is to be implemented on a particular FPGA. So in that case we have to consider the speed, power and area constraints. So as the VHDL or Verilog code should be written in a such a way that it should be optimized. So it should use a minimum resources. Because of minimum resources, it will consume a minimum area. Ultimately, it will consume a minimum power, and because of that, definitely a speed will increase. So, what is the resources here? The term resources means the utilization of our basic gates, utilization of our combinational circuit, multiplexer, demultiplexer, encoder, decoders, and utilization of our sequential circuit, flip-flop, latches, shift registers, counters, and so on. So that utilization we have to minimize while keeping our functionality exactly same. So this is the introduction of HDL language, why it is important and where to be used. So in next lectures we'll focus on the VHDL.